In this clip, I wanted to show you how to use authentication using RIP. Even though RIP isn't a very popular routing protocol, it is still used in some organizations, so I wanted to quickly run through how to configure RIP to use authentication. Like I talked about in the previous clip, RIP also uses a keychain, so we will just leverage the keychain that we created in the previous clip. Then, I will enable RIP version 2, and finally, enable authentication on each interface participating in RIP. Again, we will start out in router 1, and just to have a clean slate for this demo, let's go ahead and remove ERGRP from this router. Even though we are entering this command globally, each interface that had ERGRP 100 configurations automatically have those configurations removed, so that's pretty handy. Alright, to configure RIP, I will just enter the command router RIP, and then enable version 2 by entering the command, you guessed it, version 2. And just like with ERGRP, I will make passive interfaces the default by entering the command passive interface default, and then enabling RIP on interface gigabit 01 by entering the command no passive interface, and then specifying gigabit 01. Then I will enter the local networks on this router. Again, they are 1.1.1.0 and 12.12.12.0. And just like with ERGRP, the last step is to go into interface gigabit 01 and specify the keychain and enable authentication. The command is similar to ERGRP, but this time it is IPRIP, followed by authentication key-chain, followed by the name of the keychain we configured in the previous clip, which again is named Global Routing Keys. And then to actually enable authentication using the command IPRIP authentication mode MD5. So let's jump over to router 2 and then remove ERGRP. And then again, I will configure RIP and enable version 2. Just like before, I will make each interface passive, but enable both gigabit 01 and gigabit 02, and then specify my networks of 2.2.2.0, 12.12.12.0, and 23.23.23.0. Just so you can see how the router will respond to RIP packets, let's debug RIP by entering the command do, since we're in configuration mode, and then the command debug IPRIP. Here you can see that this router ignored the packet from router 1 because of invalid authentication. So let's turn off debugging so the screen is a little cleaner. And then configure authentication. Let's change it up on this clip and configure it on both gigabit 01 and gigabit 02. Since I'm going to be configuring this on both gigabit 01 and 02, I will use the interface range command to configure them both at the same time. And then to enable RIP authentication by entering the commands IPRIP authentication key-chain followed by the name of global routing keys, and then enable authentication by entering the command IPRIP authentication mode MD5. Router 3 is the same configuration. However, since we didn't create the keyring on router 3 in the previous clip, we will need to do that. Again, the command is key-chain followed by the locally significant name of global routing keys. Then I will create a key and configure the key string of global123 with a capital G, and then exit out of keychain configuration mode. Just like on the other two routers, I will configure RIP version 2 and set all interfaces to passive as default and enable gigabit 01. Lastly, I will configure both network 23.23.23.0 and network 3.3.3.0. Again, I will configure interface gigabit Ethernet 01 for authentication using the commands IPRIP authentication key-chain followed by the name of global routing keys and IPRIP authentication mode MD5. Let's check the routing table. I don't see the one network, so let me run that command again, and one more time. There we go. Now we can see both the one network as well as the two network, and we can tell they're learned via RIP because they're designated with the R. Lastly, let's verify that we can ping 1.1.1.1. And that looks good. In the next clip, I will show you how to configure authentication for OSPF.